this video, we're going to begin the Unit 1 Intro to Functions test review. So we're going to start with the very first question, which wants us to write a function for the graphs that are provided. So this first graph is V-shaped, which tells me that the parent function is the absolute value function. So I'm going to go ahead and start with an absolute value. I know x has to live inside the absolute value, and we want to see what has happened to this graph so that we can figure out what transformations have happened to see what the equation is going to look like. So absolute value usually starts at 0, 0, but this graph has been moved a couple of ways. It's been moved to the left, so the vertex has been moved to the left 2 spaces. If I move something to the left 2 spaces, I have to show that by adding inside of the absolute value symbol. So left and right changes happen inside the absolute value symbol with x. And if I want to move to the left, I have to make sure I use the opposite of what I might think there. I want to use a plus sign to indicate I'm moving left. So I have moved to the left 2 spaces, so I have to do a +2 inside the absolute value symbol. The other thing that's happened to this graph is it's been shifted down. It's been shifted down a total of 6 spaces. So if I want to show that I'm moving a graph down, I have to show that I'm subtracting 6 outside of the absolute value symbol. After the parent function is finished, at the very end of the equation, we're going to go ahead and show a -6. Now the other thing I want to check for, those are the obvious moves. The other thing I want to check for is if this graph has been flipped upside down, but the absolute value function is V-shaped, and this is V-shaped, so it hasn't been flipped. It doesn't look like a mountain instead of a V. And I want to check to see if it's been stretched or compressed, so I can compare the pattern happening in this graph to the pattern I would expect to see for an absolute value function. So I expect to see from my vertex that if I move over 1 space, I go up 1, and if I move over 2 spaces, I go up 2. So this is the pattern I expect to see with my vertex in the center. So for this graph, with my vertex in the center, if I go over 1, I go up 1. If I go over 2, I go up 2. So this has the exact same pattern I would expect to see, so it has not been transformed. So the only things that have happened is left 2 and down 6, and my equation is finished. Let's go ahead and take a look at the second graph. For my second graph, again, I've had some shifts happening. I still know this is an absolute value function, and I want to see what transformations have happened. So my vertex is all the way up here, even though it's usually at 0. So I can see a couple things have happened there. It's been moved to the right 2 spaces. If I want to move horizontally, I have to do that inside the absolute value symbol. And if I want to move to the right, again, it's opposite of what we might think when it's inside these symbols. So instead of adding 2 to move to the right, I'm going to subtract 2 from inside the absolute value sign. This graph has also been moved up 5 spaces. So I'm going to have to add those 5 to the end of my equation, plus 5 at the end of my equation. And those show the movement of my vertex. Now, again, the last thing I want to check for is to see if anything has happened to my pattern. So with my vertex in the middle, I expect to see over 1, up 1, and over 2, up 2. So let's check to see the pattern of this graph to see if the same thing is happening here. So from my vertex, if I go over 1, this graph does not just go up 1. I haven't met my graph again. So over 1, I actually have to go up 1, 2, 3 before I hit my equation again. So far, I've gone over 1 and up 3 on both sides. Let's check what happens when I go over 2. When I go over 2, it goes up 1, 2, 3, 4, 5, 6 on both sides. So my job is to figure out how this original pattern was transformed into this new pattern. What I can notice is all of my output values have been multiplied by 3. All of them have been tripled, so that must mean my function was multiplied by 3. There's no negative because it wasn't flipped upside down, so that concludes all of these transformations. Now that we've looked at writing equations based on the graph, let's go ahead and take a look at writing the transformations based on the equation. So here we are describing with words how the parent function has been transformed in the following functions. So our parent function is x squared this time. That's a parabola. And it says, for example A, I have a -2 in front of x squared, and I have a -3 at the end. That's going to cause 3 different changes. First and foremost, the negative in front is going to flip my graph upside down. That's a reflection. So I'm going to say that reflects over the x-axis. Up next, the 2 itself does its own thing. The 2 is going to take all of my y values and multiply them by 2. So that's going to double the height of my graph. So we're going to call that a stretch. That is a stretch by 2. And last but not least, the minus 3 at the end. It's not inside with x before the exponent happens. It's at the very end of the equation. So that's going to take all of my y values and subtract 3 from them. So that's going to shift me down 3 spaces. Let's go ahead and take a look at the transformations for my second function. I have, again, 3 things are happening here. In the very front, I have the number 1/2. That 1/2 in front is being multiplied by my y value. So all my y values are going to be half what they would usually be. And that means that my equation is going to get shorter. So that's going to be called a compression. So we are going to compress by 1/2. I also have a minus 2 inside the parentheses with x. So that's going to directly change my x values, and that means that I'm going to move side to side. If I'm changing my x values, I'm going to move horizontally. So this is the one where it's opposite of what we might think. If it's inside the parentheses with x, it's going to change the direction that I'm going. The minus 2 is going to move me to the right 2 spaces. In order to find out where exactly it's going to move me on the x-axis, I would need to solve for x. So I would do x minus 2 equals 0, and I'd have to add 2 to both sides. That's where the positive 2 comes from. But we can just remember that if it's a minus inside the parentheses, we do the opposite. We go to the right. If it's a plus, we think of our positive influence, Miss Beyonce. She moves things to the left, to the left. All right, last but not least, I have a plus 5 at the end. That, again, is at the end of the equation after the x is finished. So it's taking all of my function, my y values for my function, and it's adding 5. That's going to move us up. So up 5 spaces. So we have gone ahead and described these transformations. Now, the last thing on this front page of the review is to describe in context what transformations are doing. So let's go ahead and take a look at question 3. Question 3 says we have a stone that's being dropped from a bridge. The bridge is 40 feet above the water. And the equation for the height of the stone is negative 16t squared plus 40. See, we can see that 40 is that height of the bridge, the initial starting height of the stone. I want to figure out what effect h of t plus k would have on the context of this problem. So I want to know what that plus k would do to the story. That means I have to take my function and I have to add a number to the end of it. So my function is 16t squared, negative 16t squared plus 40. My job is to add a number to the end. And the first number I want to add is the number 15. So let's go ahead and see what adding 15 would do to this equation. So negative 16t squared plus 40, if I add 15, that 15 is going to combine with the 40 that I already had, and that'll change this to negative 16t squared plus 55. So if I want to figure out what that's going to do to the story, I have to figure out what the 40 meant and what this new 55 means. Well, the 40 was how high this stone was above the water. It was being dropped from a 40-foot bridge. Now it's turned into the number 55. So that means that this stone is being dropped from 55 feet instead of 40 feet. Now, it's not my job to figure out why that happened. All I have to do is describe what the effect was. So it was dropped from 55 feet instead of 40 feet. If we did have to explain some sort of scenario why that could have happened, it could have been that we found a higher bridge to drop it from. Or maybe we stood on a 15-foot ladder on top of the bridge and raised us up even higher. But the end result is the same. The end result is that the starting height of the stone was raised up by 15 feet. Let's see what the effect would be if I had this minus 10 instead. So that would be my original function, negative 16 t squared plus 40, and this time I am going to subtract 10 from the end of the equation instead. Well, that would change me into the equation negative 16t squared plus 30. So the effect here is that instead of being dropped from 40 feet, now I'm being dropped from 30 feet. So the stone is dropped from 30 feet instead. So it's getting 10 feet lower. So again, that's all we have to say, is that the starting height is 10 feet lower, or the stone is being dropped from 30 feet instead of 40. So we can see the effect there on the story. And if I wanted to, or if it asked me for a scenario why that would happen, maybe the stone was dangled below the bridge before it was dropped, or we found a lower bridge or something. So some scenario where the stone was being dropped from a lower height. So those are the effects on my story. We're going to go ahead and pick up with the next page of our review in the next video.